Hello everyone. Today the paper I will present is Seeking No Sins, Looking for Trouble, Efficient Promotional Infection to Detect Through the Systematic Inconsistency Search. My name is Xiaojing Liao from Georgia Tech. This is a joint work from Georgia Tech, Indiana University, and Tsinghua University. When you visit a UIUC official website, can you believe they are selling Viagra? Apparently, they are doing so. We take advantage of search engine to find this kind of compromised website. For example, when you search no prescription on EDU domains, you will shocked by the search result. Harvard is selling Levitras. Also, if you search cheap asset in EDU domains, you will find Yale University is doing essay cheating business. When you search by Civalis on United States Department of State website, can you believe state.gov is selling Civalis? When you click into it, you will find the whole article is original. However, the attacker inserts a link to sell Civalis on this government webpage. It's difficult to rely just on human beings to identify this illicit link. We noticed that this site had been compromised for illicit advertising, such as selling Viagra, counterfeit luxuries, and essay cheating. We call this such attack promotional infection. Promotional infections are hard to detect. These attacks often do not use malware download and therefore cannot be easily detected by antivirus tool. Moreover, the content injected into the compromised website can appear perfectly normal, no difference from the legitimate ads. So far, detect promotional infection mostly rely on community efforts such as the discovery by human visitors or integrity check by the website's owner. A fundamental solution can be semantic check, which leads to a new question: how to analyze the semantic of massive web page. To conduct the semantic inconsistency check, let's record what the semantic inconsistency of a website. Intuitionally, when a university website is used to sell Viagra, it shows semantic inconsistency. Then another question appears: can we quantify this semantic inconsistency from intuition to a number so we can conduct a large-scale detection? NLP provides good solutions for us, which is the content extraction and word embedding. Content extraction extracts the critical words from a text, and the beautiful word embedding map a word into a high-dimensional vectors, and these vectors represent the semantic of a given word. For example, a vector of poppins and dolphins is closer than the vector of Paris in the terms of cosine distance. Hence, we can use sliced word embedding to quantify semantic inconsistency after extract the content tense. Our current study focuses on detecting sites with sponsored top-level domain, which we call STOD, such as .edu, .gov. All of these STOD sites carries explicit semantics, such as the websites of EDU STOD is required to be United States affiliate institutions. We will show how we use word embedding technique to quantify the semantics of 403 STOD sites from 141 countries. Then we try to seek an answer to make the semantic analysis efficient. How about use the web page as the source of semantic analysis? We don't think it's a good idea. First, the web page is complicated and has multiple elements in it. Extract content from it introduces heavy tasks. Also, if the injected content is mixed with the original content, the performance of semantic analysis will be degraded. In our project, we use search engine results as a source for semantic analysis of a site. Search engine result includes 3 elements: title, URL, and snip, which is a short description of the website. The description in the search engine result represent and summarize the web page and their relations to user's query. Consider their representative, we utilize the data from search engine results and their page description for semantic analysis. Note that the whole process of our system only relied on search engine results. Altogether, for semantic inconsistency check, we come up with the idea to use the most irrelevant terms to generate a search engine query. For example, to find those potentially compromised websites, we search the term casino on edu domains. Then the search engine results pop out this query edu sites with semantic inconsistency. For example, finding Viagra selling on Stanford, which we report and they confirmed. However, many question marks still there. While we use casino as the most irrelevant patterns for edu site semantic inconsistency check, are all the sites in search results compromised? How about a page talking about casino revenue research? Third is how to systematically generate other backterms for edu domain. Now I will show our system SIS to answer these 3 questions. First, why we use casino as the most irrelevant patterns, which we called IBT for edu sites semantic inconsistency search. To find the most irrelevant patterns for search query, we compare the semantic gap between the STLD and the settled patterns. As I promised earlier, we will show how we quantify the semantic of STLD. Specifically, we determine the semantic terms of a given STLD and make them into a vector by word embedding technique. We extract the content terms using the MLP content term extraction tool from the wiki page of STLD. Then, we compare the consent distance of STLD content terms and the patterns. So the semantic comparator outputs the pattern candidate with the largest semantic gap with the semantic terms. Then we use these most irrelevant patterns to feed the search engine. Then we try to suppress false positive in the search results. In SIS, we conduct a differential analysis on context analyzer to reduce false positive. Here we show 2 examples to describe how it works. First one is false positive, a casino marketing course on a university in Las Vegas. And we search casino on University of Nevada, Las Vegas website, and we extract the terms from the search result, such as course, education, and student. If you search the original website, you will get a similar terms. So the cosine distance between these 2 search results is quite small. But the true positive is quite different. When you search casino on University of Arbor, the terms of search results are gambling, slot machine, etc., which is quite different from the original sites with the terms of students, educations, graduations. So the cosine distance is large. In this way, we suppress false positive with the large cosine distance. Before now, we utilize a given pattern set for inconsistency search. How can we expand this pattern set? We utilize a snip of the confirmed compromise site we got from the previous step to harvest the pattern set. Then the extended pattern set will be used for inconsistency search. 2 kinds of expansion is done. The same category expansion like to expand patterns casino to slot machine, and cross category expansion like to expand casino to Viagra. We detail this process in paper. Our system SIS works well in practice. We set up the system evaluation on 3 datasets. The bad set, which includes 300 FQDNs and 50 patterns from CleanMX. And the good set is the legitimate search output under these 50 patterns in the bad set. For the unknown set, we use 403 STODs and 30 patterns, which come out with 100,000 FQDN, which is STOD size from Google and Bing search. And we found 11,000 of them are compromised. So the evaluation results on label and unknown datasets show high accuracy and coverage. Specifically, we got 0.5 false detection rate and 90% coverage on the label set, and 1.5% false detection rate and 90% coverage on the unknown set. For the irrelevant pattern set expansion, we expand 30 patterns to around 600 patterns in only 20 iterations. Also, SIS is efficient to find a compromised website in only 2.3 search engine queries. SIS output 11,000 infect STOD domains across the world. We observed that the Chinese government website and US education websites has significant portion of compromised FQDNs. And we have reported this compromised site to CERT and CCERT, and they confirmed our finding. Multiple kinds of illicit advertising are involved, such as gambling, drug trade, and academia cheating business. Most of the FQDNs were compromised for casinos promotional, such as California's government sites. Also, MIT sites was compromised for selling acid. Almost all the top-ranked STOD sites were injected, such as state.gov, MIH.gov, and so a similar situation happened in the top university websites, such as MIT, Stanford, Harvard, Berkeley, etc. Besides, we observed large amount of campaigns. The largest one is used for gambling promotion involving 800 STODs and 4,000 general TOD sites across 20 countries. When compared the Alexa rank of these STOD sites and GTLD sites, we found that 60% of STOD sites in Alexa top 1 billion, which is only 15% of GTLD sites at this level, similar to their page rank. This means that STOD sites are valuable to adversary because of its less protected and highly ranked. Besides STOD, we extend the semantic inconsistency search to general top-level domain, GTLD, which is detailed in our paper. In conclusion, we show the semantic inconsistency check for promotional infection detection. We implemented SIS, which have a very good performance in the wild, and also a measurement study on 11,000 infected STOD sites is presented. That's it, and happy to have comments.
Really nice talk. So if I was an attacker, I would have put casino in all the pages of a university so that your differential analysis does not work. Have you noticed anyone doing this kind of thing?
You mean the compromise, the whole, for example, the main domains
Yes.
of the...
Yeah.
Yeah, but it's really difficult for them to do so. And for example, we use a search engine query, which pop out the highly ranked website, which is much difficult for them to do this in a while.
Okay. So if you were an attacker, how would you go about evading your system?
Yeah, maybe we can evade the Google's summarize of this web page, for example, because we rely on the search engine results of the Google.
Injure from Lehigh. So I have a question. Is the bad content stored at the server side, or is kind of like delivered by a JavaScript that can modify it at the client side?
Pardon, can you repeat it again?
So is the bad content, for example, like a casino, is directly stored at the server, like uiuc.edu, or it is a JavaScript from the third party, and the third party will modify the web page and then deliver casino content?
Yeah, both situations may happen, but all of them will be indexed by Google. That's why we can find it.
Yeah,
and it's used for promotional, and it should have been indexed by Google.
Yeah, I'm just interested in the statistics.
Yeah.
Thank you.
Both situations happen.
Yeah, Kurt Thomas, Google. So when you listed all of the topics you were finding, like travel and everything else, politics was the very last one. How did you catch those semantic terms, and what actually were you getting? Is it defacement or something else?
Sorry, I did not get the very first part.
Okay, so when you have that political query and you did this semantic search, you started from casinos and you expanded out, how did you basically make that leap from something that's traditional like SEO monetization to something that's politically focused?
We got the semantic of the STLD from the Wikipedia's page. The word embedding, fundamentally, what the word embedding is to got a vector to one word to other words to get this vector, and the other words we got it. The other words is mean that we got from the Wikipedia page, such as, for example, when you're talking about educations, the wiki page may also talking about graduations. So they will have have each values on these terms, and which generate vectors.
And for the content that was actually injected, was it like defacement or was it something else?
Sorry?
The content that was injected, like you mentioned, Falun Gong was on there and a couple others. Like, was that like politically motivated defacement, or was it some sort of monetization scheme going on there?
Sorry, what is the example you give?
So in the table you had, sorry, at the very bottom, it basically said politics,
Okay.
and then you said some of the terms that we were finding.
Okay, politics.
One back from here, I think. Very bottom. Islamic
Okay.
State, Falun Gong, and others. Like, who is injecting that content, and like, is it basically defacement of the sites, or what's going on there?
Yeah. We got this. In fact, this terms is we generate. We use the content extraction to generate from the description of these sites. For example, government site compromised by IS, and the Google's description we have maybe hacked by IS hackers or something, and we extract these terms.
Okay, thank you.